I think that's what we kind of always talk about in the Chesapeake is, our ultimate goal is improve water quality so we have living resources and have plenty of crabs to eat. So just as a clarification, when I say fish, I mean crabs and oysters and all that sort of stuff. I mean kind of general fisheries. As my job as ecologist slash ecosystem modeler at the Chesapeake Bay office is focused on moving us towards ecosystem-based fisheries management, and that's what this is all about. Tying in water quality to fish and the fish interactions and habitat interactions, and feeding that back to the resource managers to make some decisions, taking into account trade-offs and interactions and that sort of thing. So that gets quite complex, and so hopefully we're building ways to deal with that complexity. So first, I just want a little background on ecosystem-based fisheries management and what the fisheries goal team is up to. And so I have 5 slides, no more slides, and it'll be all fun stuff after that. So this is a picture from the 1500s. It's from Peter Bruegel the Elder, a Netherlands painter. So 1500 years ago at least, or 500 years ago at least, we understood that big fish eat little fish, and that's the title of the painting. So you see a big fish here with a bigger, smaller fish, all inside. We've kind of understood that for a while. Fisheries management has not always taken that consideration explicitly, but we understand that. We also know that fisheries provide, human activities affect fisheries, right? And we also get a lot of services and goods out of fisheries. So, whether it's nuclear radiation or oil spills or just fish hugging, we do things that affect fish. And we also extract goods and services from fisheries, whether it's seafood or fish pills or exfoliation or fish flops. We all extract resources from fisheries, right? And so we've understood that, and now in the region, we've made some attempts in the past and laid some groundwork for ecosystem-based fisheries management. Most notably in 2006, we came up with the Fisheries Ecosystem Planning book, the big book that was published by American Fisheries Society. That was a book put together by several people in the room and a lot of fisheries folks in the region, kind of headed up by our Chesapeake Bay office. And now we're kind of moving towards the next steps. A couple of years ago, Sea Grant got started in sort of building the scientific and technical support end of moving towards ecosystem-based fisheries management. So this is sort of the structure they've been using for that. It was the Fisheries Ecosystem Work Group, or FEW, and that is comprised of some species-specific teams, sort of our focal species in the Chesapeake. Not the only important species, but the focal species. And then some quantitative ecosystem teams, habitat, stock assessment, or stock status, they say now, socioeconomics, and food web. And so I sit in that group and focus on food web things, but I'm also concerned about, this is some complex information, how do we communicate it? So that group, is kind of summarized down here, feeds into the fisheries get, and then, as I said before, all the stuff that everybody's doing here also feeds into what affects fisheries, right? And ultimately, since a lot of these fishery species are coastal species, there's already a law in place that says we got to work with the Atlantic States Marine Fisheries Commission to make some resource management decisions. So striped bass, we make some decisions here, but we also have people up in New Jersey or down in South Carolina along the coast contributing to some of those decisions. The other important point is, I've worked with some of these fisheries managers like at DNR or Virginia Marine Resources Commission. They go to an ASMFC meeting where they have stock assessments for, whatever the focal species for that quarter is. So they have quarterly stock assessment or management team meetings for each species of fish. They get these stock assessment documents, somewhere between 100 and 200 pages, depending on how well studied the fish is. And for the week, they probably have 2 or 3 per day they look at. So we're talking 12 books, essentially, they're supposed to read beforehand and make some decisions about a stock. Okay, I mean, not just them, they have staff and stuff, but that's a pretty big task to ask of somebody. And now we're coming along and saying, well, what else you need to be considering is all the stuff that's going on in the Chesapeake with water quality, and they realize that, but it's a tall order. And so, but we are moving towards that direction, building this GIT, and I think I mentioned earlier that this GIT, the Fisheries Goal Team is going to have their first sort of meeting, full-fledged meeting next week. The executive committee has been meeting and sort of laying things out, but the full-fledged meeting will be next week. And here's just a short list of some of the participants in that meeting. representatives from these agencies. So now you've got people who've read all these fish documents they've read in the past, and then people who aren't at all familiar with fisheries, or not to the level some of the fisheries managers are. So you have Virginia Department of Environmental Quality, other groups like that they don't speak what I call fisheries. It's a different language. So what I see as a potential problem here is we need some tools to be able to communicate across these different disciplines, and otherwise we're going to end up with a Tower of Babel situation where nobody's speaking the same language. You get something half built, and then everybody goes home because they can't understand each other. Here's my little trick. This is also a painting by Peter Bruegel the Elder. Okay, that's it for slides. Let's get into the fun stuff. So the fun stuff. One of the tools that we're working on in our ecosystem modeling team, our ecosystem science group at NCBO, is this software called EcoPath with EcoSim. I know a lot of the modeling folks here have heard me talk about this a bit, but I did want to let everybody here see it run one time. So basically what I do with this, this tool was built over a series of several years of workshops with fisheries experts from the region, helping us to understand what's some initial estimates of biomass of different species. We have 45 different species in there. What fish eats the other fish, that kind of put some actual numbers to that picture we saw at the beginning of the slideshow. And think about how primary production drives that whole food web. And when you kind of put all that together in the first sort of snapshot, so this is a snapshot of what the bay looked like in about 1950-ish. It's a pretty clear picture here. You kind of see all the connections, and I'm going to take this to a fisheries manager who's read now 12 documents, 100 pages long, and then get into this detail with them. It's like probably not going to get very far with that. It gets confusing, right? So what we really want to do is not worry about that static picture, but think about dynamically. Start thinking about what if scenarios. What if I did this to a fishery or that to a fishery? How would that affect things? So one way we can do that is to actually take that EcoPath snapshot and put some system dynamics in there and let some time dynamics and let things run. And so now we get a much clearer picture of what's going on, right? When we run the model and let things show up. It's still very complex. Now you can drill down and sort of look at individual species things here. We can look at kind of overall snapshots, or we can look at how well we fit to the data. So we're making it a little simpler, but still that's pretty complex and asking a lot of somebody to digest all that, especially somebody who's maybe not as familiar with fisheries. So but still, I think the notion of looking at trade-offs. I should just mention one other thing. One of the things that's driving all this is a primary production forcing function. So this is sort of a time series. We built another model that just generates this time series for us based on historic nutrient loads and winds and that sort of thing. To get just a rough sense, I wouldn't do water quality management based on this, but we do want to understand how primary production has changed over time for the past 50 years in the bay. So that drives a lot of those initial simulations. So that's also neat because it gives us a hook to think, well, anything that affects primary production, water quality, stuff happening in the watershed, we can potentially capture in this model and let it magnify up the food web. So there's some really cool things you can do here, but it does get to be really complex, especially when you start exploring fisheries policies. One of the policies I've explored in the past is what if we had a severe restriction on menhaden catches? That's been a hot button issue. And I won't get all the way into it, but right now, it shows things like, well, yeah, you have an increase in menhaden population, which would lead to an increase in striped bass populations. And we say, great, that's what we want. Like, but you increase the striped bass population, striped bass also eat blue crab, so there's a potential that you would decrease the striped bass population. So those sorts of things that are sort of non-intuitive, you want to be able to explore a little bit in the models, and also explore what if you now layer on the top of those fisheries management decisions some water quality management decisions. So the other direction we've been building on a bit and have put it on hiatus for a little while, but is the folks who do this EcoPath with EcoSim got a big grant from the Linfest Ocean Program under the Pew Charitable Trust to totally reprogram EWE. So this was version 6 I showed you. Version 1 actually was developed by NOAA in 1984, where they looked at Hawaiian reef ecosystems to do EcoPath. And then since then, Daniel Pauly and Billy Christensen and Carl Walters, who are all now at the University of British Columbia, have built upon that, and we're now at so up to version 5, it was always a bunch of biologists who had taken some computer classes programming. Now, if you can imagine 20 years of biologists programming, it got to be some pretty rough code. I tried to tinker with it to change things, like, wow, I'm kind of scared to do this. I might change the color of something, but that's about as far as I was willing to go. So they've actually hired a bunch of professional programmers who understand software architecture and stuff to reprogram, make it more modular, make it where you can, instead of having that forcing function, maybe actually plug in a ROMS model, sort of alluding to what Doug was talking about earlier. So you could have, more realistic, lower trophic level things and physical things driving the ecosystem. And they also made it modular, so you don't have to have those graphs of lines and dots, but can actually start looking at, well, they kind of want to move towards the direction of using computer-generated images and a decision support tool where you can kind of swim around and see the ecosystem, and also have like a set of simple indicators. So you would, in the system, the model's running in the background. You don't even think about all that stuff I just showed you. That's running in the background. You're just pushing buttons and looking at changes in indicator scores and looking at changes in the population. So this is sort of a mock-up of that. This is not currently running on the model, just sort of the mock-up. But the programming has now occurred that you could, this is sort of the mock-up screen. Okay, this isn't really the Chesapeake. We don't have tuna here in the Chesapeake. It's just sort of a random ecosystem where all good things exist, like tuna and striped bass. And you'd have multiple other controls, but the idea is on one side you'd have sort of controls, things that affect the watershed and water quality. On the other side, things that affect different fisheries. And you can sort of say, all right, let me, I'm going to take into a management action that's actually going to increase pollution or, nutrient loading. So you see the nutrients going in there, you see the water turning greener, getting darker. It's running slow again. I think the electricity is slow around here, but you also see the populations, you should be seeing them decrease a little bit. It's running a little bit slower. Then you can also make decisions, say, well, I actually want to fish a lot more fish too. And so they start swimming into the net over here, and you start to fish down some populations. And you can, just sort of, yeah, oops, yeah, exactly. But that's what you want managers to do, sit around and do oops on a computer model and with graphics, not in the real world, right? You don't want people to make decisions like that. You want to do sort of this management strategy evaluation. Oh, like I just left this pipe running, so it really got green in there. But that's exactly the sort of thing you want to bring managers together to do. And I think this sort of environment would be a much more engaging thing to explore policy versus, let me hand you a stack of 12 150-page documents and we'll talk next week. So that's where I'm going. This also, during your, well, you see the running sort of, you can have whatever indicators. These are just some general ones, biomass of whatever species of fish. Jobs, well, if you're fishing a lot, jobs go up. Ecosystem structure, well, you fished a lot, so maybe the structure went down. Economy, so things that are important to policymakers and decision makers. Now, under these would be several other indicators that, to kind of feed to these major indicators. So they're doing that sort of programming for this system, and I'm still sort of plugging away on it. We've also developed some specific CGI graphics for the Chesapeake Bay, and I have a little movie on that, but let's just watch that during lunchtime, why don't we? Just because it was designed for education, not for sort of policy, but just so we could have a menhaden drawn and a blue crab drawn and a striped bass and an oyster reef. And so it sort of gives the history of the Chesapeake based on CGI animation.